This is Pepijn from Team 4. For our project we are building a Game Boy emulator. We decided to use the Raspberry Pi to implement the CPU of the Game Boy, because the Raspberry Pi is fast and good at sequential execution, and use the FPGA to implement the GPU of the Game Boy, because it's slower, has a slower clock speed, but can do more parallel tasks. Our Raspberry Pi communicates with the FPGA over an SPI connection. We use SPI because while a parallel connection would in theory be faster, in practice toggling the GPIO pins on the Raspberry Pi is slower than using the hardware SPI interface, which can go up to 100 MHz and even higher. The DE1 drives is connected to the FPGA monitor and sends back synchronization pulses to the Raspberry Pi. And this is needed to avoid tearing and also to support games that update graphics mid-screen. The Raspberry Pi runs a modified emulator, because writing an emulator from scratch within the project is infeasible. We used an interface that implements the external memory, which has two implementations, one for testing and one for the actual SPI. This allows us to better test the code before connecting it. We select specific memory ranges we want to write, because I/O is slow compared to CPU speed. What was not implemented is batching writes over SPI. This could give up to 3 times performance gain, because you spend less time writing addresses, but in practice this was not needed. The DE1 as said drives the FPGA. In the basic scenario we would use one sequentially clocked memory, but we found a better way, which is to drive the SPI slave from the SPI clock, which makes it possible to go faster than the internal clock of the FPGA. But this means you need to synchronize with the FPGA. The way we solve this is using 2-port RAM. So there's one write port for the SPI sleeve and a read port for the rendering. Additionally, we choose to split up the RAM, because the read cycles were the bottleneck in the rendering code, and by splitting it up in multiple RAM blocks, memory reads could be parallelized.